We are going to look at trigonometry problems. The first question here says convert 135 degrees to radians. Previously, we looked at conversion of degrees to radians and vice versa. And we did say that anytime you are asked to convert a number from degree to radians, there are conversion factors. For instance, anytime you are asked to convert from degree to radian, you are using the conversion factor. For instance, 1 radian, that is 1 rad in short, is equal to 180 divided by pi. Whereas 1 degree equal to pi over 180 degrees. So with these conversion factors, anytime you are converting a number from degree to radian, you are using pi over 180 degrees. That is changing degree to radian. But if you are changing radian to degree, you are using 180 over pi. So since this question says convert 135 degrees to radians, we are going to use the conversion factor here, pi over 180 degrees, because the question is given in degrees to be converted to radians. So what we'll need to do is to multiply the conversion factor by the value given to us. The value given to us here, we have 135 degrees. Multiplied by the conversion factor here, we have pi over 180 degrees. And that's equal to 135 pi divided by 180. The common factor between 135 and 180 here is 45. 45 will enter 35 3 times. 45 can enter 180 4 times. And so we have 3 pi in the numerator and 4 in the denominator, such that the final answer is 3 pi over 4. And that corresponds with option D. So option D, 3 pi over 4, is the value in radian for 135 degrees. The second question here says, given that tan theta is equal to 3 over 4 and theta is acute, we have to find sec theta with these options. So the first thing we need to do is to bring in a right angle triangle. Theta is an acute, and then an acute angle is an angle that is less than 90 degrees. So let this be angle theta, and let this right angle triangle be labeled ABC, triangle ABC. Tan theta simply is equal to opposite over adjacent. So the opposite side to this angle theta is this place. So if tan theta is equal to 3 over 4, meaning that the opposite is 3 and the adjacent is 4, the opposite side to this angle theta will write 3 here. And then the adjacent will have 4. Now we are left with the hypotenuse. And for us to get the hypotenuse, which is line AC, we are going to do that using Pythagoras theorem. Using Pythagoras theorem, we will have AC, that's AC square, it's equal to AB square plus BC square. AC square will be equal to AB here, which is this line, is 3. So we have 3 square plus BC square. That is BC is 4, so we'll raise it to the power of 2. And that's equal to AC square equal to 3 square we have 9, 4 square we have 16. Implying that AC square is equal to 25. We are looking for AC, not AC square. Therefore, we will find the square root of both sides. And by that, we will have AC on this side of the equality sign equal to the square root of 25. And the square root of 25 is equal to 5. Implying that this side, AC, is equal to 5. So if our tan theta is equal to opposite over adjacent and is equal to 3 over 4, we are asked to find sec theta. And sec theta simply is equal to 1 over cos theta. That is the inverse of cosine. So if we look at this right angle triangle, cos theta is equal to adjacent over hypotenuse. From our SOHCAHTOA, you see that whenever we are dealing with sine, it's going to be opposite over hypotenuse. C here represents cosine. Anytime we are dealing with cosine, we are going to use adjacent over hypotenuse. YT represents tan, opposite over adjacent. So for cosine here, we are going to use adjacent over hypotenuse. And our adjacent here is 4, while the hypotenuse is 5. So for cos theta, we are going to have 4 over 5. But it is sec theta we were asked to find. And sec theta is equal to the inverse of cos theta. That is 1 over cos theta. So if cos theta is equal to 4 over 5, inverting this, we are going to have 5 over 4. That is 1 over 4 over 5. This is the same thing as saying 1 divided by 4 over 5. And taking the reciprocal, this is same thing as saying 1 multiplied by 5 will go up while 4 comes down. So we have 5 over 4. And that is equal to 1 times 5, we have 5 over 4. So we have 5 over 4. Therefore, sec theta is equal to 5 over 4. We can find other angles like sine theta, cosec theta, cotan theta. So the corresponding option to this particular question for sec theta, we have option B, which is 5 over 4. The third question here, we have to convert pi over 3 radians to degree. Pi over 3 radians to degree. Again, we'll bring in the conversion factors. The conversion factor from degree to radian, we have pi over 180 degrees, while from radian, we have 180 over pi. So for this particular question, we are asked to convert from radian to degree. So the conversion factor that we are going to multiply pi over 3 by is 180 over pi, because we are converting from radian to degree. So that we have pi over 3 multiplied by 180 over pi. And that's equal to pi times 180, we have 180 pi, divided by 3 times pi, we have 3 pi. 180 pi divided by 3 pi, that's equal to 60 degrees. So what we have here, 60 degrees is the equivalent of pi over 3, corresponding with option B. If sine x is equal to 2 over root 5, we have to find cos x. So to attend to this particular equation, we have to bring in a right angle triangle labeled x, y, z. So we have this angle here. Our subtended angle is this way. Based on this question, we are asked to find cos x if sine x is 2 over root 5. And sine of angle is equal to opposite over the hypotenuse. And based on the information provided here, our opposite is 2, while our hypotenuse is root 5. So from this, we will have on the opposite side to angle x, we are going to have 2, while the hypotenuse will be root of 5. The next is to look for the adjacent. And to do that, we are going to solve using the Pythagoras theorem. Using the Pythagoras theorem. Now, since it is the adjacent sides that we are looking for, we are going to subtract the square of side yz from the square of side xz. That is xy squared, that is this adjacent side, will be equal to xz squared minus yz squared. That is this side, the square of it minus the square of this side. And that's xy squared equal to side xz here, we are going to have root of 5, we'll square this, minus side yz, that is the square of it, that's 2 square, xy square equal to root 5 square is equal to 5, because this square root will go with this square, and you are left with 5. Minus 2 square, we have 4. And that implies that xy square is equal to 5 minus 4, we have 1. And to get xy, we'll find the square root of 1. And that's equal to 1. It means the adjacent side of this right angle triangle is equal to 1. So since the question says that we should find cos x, cosine of angle, cos x therefore will be adjacent over the hypotenuse. And the adjacent of this right angle triangle has been found to be 1, while the hypotenuse here is equal to root of 5. So cos x in this question is equal to 1 over root 5, corresponding with option A. The last question for now in this section, if cos theta is equal to root 3 over 2 and tan theta is negative, we are to find sin theta. Again, we need an acute angle, that is a right angle triangle here, to address this question. So let's label this triangle ABC with angle theta this way. The cosine of angle is equal to adjacent over the hypotenuse. So by that, cos theta up there we are given as √3/2. So transferring that information to this right angle triangle, our adjacent here will be √3, while our hypotenuse will be 2. Implying that we are going to look for side AB before we can proceed to find sine theta of this particular equation. Using Pythagoras theorem, since we are looking for the opposite side, we are going to subtract the square of the adjacent from the square of the hypotenuse. That is, AB square is equal to AC square minus BC square. AB square is equal to, our AC square will be 2 square, while our BC square will be the square root of 3 raised to the power of 2. AB square will be equal to 2 square, we have 4, minus square root of 3 raised to the power of 2 is equal to 3, because this square root will go with this power of 2. And we have AB square equal to 4 minus 3 is 1, such that AB is equal to the square root of 1, and that's equal to 1. It means this side AB, which is our opposite side, is equal to 1. So if we are asked to find sine theta, sine of angle is equal to the opposite over the hypotenuse. So by that, sine theta will be equal to, this is the opposite side, and then this is the hypotenuse side. So that will be equal to 1/2. However, from the question that were asked here, they said tan theta is negative. So they said if cos theta is equal to √3/2 and tan theta is negative, we are to find sine theta. It means we are bringing about the issue of the quadrants. So we need to take into consideration the sign. Is it going to be positive 1/2 or negative 1/2? And that's the very reason why the two options are here, for you to apply correctly your knowledge about these trig ratios, number 1, and then the 4 quadrants that we have to pick the correct option. So let's look at the quadrants again. When you have this circle, and then our 4 quadrants represented here, this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant, moving in the anti-clockwise direction. And of course, that is how we get positive angles. While movement in the clockwise direction gives us negative angles, movement in the anti-clockwise direction, we have positive angles. So in the first quadrant, all the trig ratios, the sine, the cosine, and the tan, they are all positive. So here we have all positive. But in the second quadrant, you have only sine theta to be positive. So here we have plus sine, cos is negative, tan is negative. You come to the third quadrant. Here, only tan theta is positive. So we have the sine of angle here is negative. The cosine of angle here is negative, while the tan is positive. And when you now come to the fourth quadrant, you have sine theta to be negative, cos theta to be positive, and then tan theta to be negative. Implying that when you have these four quadrants, it means in the first quadrant, all of them are positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. And then in the fourth quadrant, only cosine is positive. So in this question given to us, you discover that cos theta here is positive. That is root 3/2 is positive. And they are saying tan theta is negative. So what is sine theta? So we'll go back to the quadrant and see the place where cos theta is positive and tan theta is negative. When you come back to this our quadrant, you discover that the first quadrant, all of them are positive. So that is not the quadrant that applies to this question. When you go to this second quadrant, sine is positive, cos is negative. Because cos is negative here, we cannot use the second quadrant for that question. So we'll come to the third quadrant. Again, cosine here is negative, but in the question given to us, root 3/2 is positive. So it means the fourth quadrant is where you are having that data from, where the cosine of angle is positive, and then we are told that the tangent of that angle is negative, implying that the sine too should be negative. Cos theta is positive. They said tan theta is negative, so sine theta too should be negative. So according to this question, the sine theta that we are having here is supposed to be negative 1/2. And that corresponds with option C. So if cos theta is equal to root 3/2 and tan theta is negative, the value of sine theta is equal to negative 1/2 because it is in the fourth quadrant.